This is an instructional video aimed at orthoptic students to further educate them about the clinical skill of subjective refraction. Subjective refraction is an attempt to determine, by trial and error using the patient's cooperation, the combination of lenses that will provide the best corrected visual acuity. The aim is to improve current unaided vision or vision with current glasses. Throughout this examination, the orthoptist will use the following equipment: trial frames, trial lens box including pinhole and occluder, Jackson cross cylinder, which is a combination of two cylinders whose powers are numerically equal and of opposite sign, and whose axes are perpendicular to one another. This is used to search for astigmatism. Snellen chart, and the duochrome, which is used to check the spherical component of the refraction.
I'm Tash, I'll be the orthoptist for today, and this is Hongbin, our patient, and we've just induced astigmatism for the purpose of this video.
Before beginning the assessment, the patient should be seated at a 6 metre distance from the Snellen chart. The test must be performed under bright lighting conditions. Setting up the patient. Initially, the orthoptist will fit the trial frames onto the patient by tightening the arms, adjusting the nose piece, and adjusting the IPD so that it sits comfortably on the patient. Conventionally, the right eye is tested first, so the orthoptist will place the occluder in front of the left eye. The orthoptist begins with testing the patient's visual acuity in their right eye.
Okay, Hongbin, I'm just going to get you to look up on the chart for me then, read down to the lowest line you can read.
A.
Yeah, can you get down any further?
No, I can't.
In this case, the patient's visual acuity without correction in the right eye is 660. The orthoptist then places a pinhole in front of the patient's right eye. The pinhole is used to assess the patient's potential best corrected visual acuity by blocking out the peripheral rays so that only the principal ray falls on the fovea, decreasing the size of blur circles.
Okay, Hongbin, so I'm just going to get you to look up at the chart and do the exact same thing as last time. Just read down to the lowest line you can see now.
Now I can see the fourth line. They are A, O, H, T.
Yeah, and can you get down any further for me?
No, I can't.
With the use of the pinhole, Hongbin's vision has now improved to 618. The orthoptist aims to equal or better this level of visual acuity by the end of this assessment. Step 1. Initial best sphere correction. A patient without astigmatism should be fully corrected after this step alone. However, if astigmatism is present, the aim of this step is to position the two focal lines so as to straddle the retina. This is known as the circle of least confusion. First, we need to establish whether the patient is myopic or hypermetropic, therefore determining the need for a minus or plus lens to correct their refractive error. Using the plus 0.5 dioptosphere lens on the confirmation set, hold the lens centrally in front of the patient's right eye, asking them if the letter is clearer with or without the lens.
Okay, Hongbin, I'm just going to get you to look up at the letter A for me there. And I'm just going to get you to tell me whether it's better with or without the lens.
Without the lens.
The patient's vision did not improve with the plus lens, therefore the minus lens will now be tested.
Yep, and just tell me again the same thing. Is it better with or without the lens?
With the lens.
Because the patient preferred the minus correction, the orthoptist will place the minus 0.5 lens into the trial frame and then continue to see if the patient requires further correction. With minus lens correction, it is crucial that the orthoptist asks the patient if they are actually seeing the letter clearer or if it is just smaller and darker.
So I'm just going to get you to do the same thing for me. Tell me if it's clearer with or without, or is it just smaller and darker?
Clear with.
The orthoptist replaces the minus 0.5 lens with a minus 1 lens. This process continues until the patient states that their visual acuity is the same or the letter is just smaller and darker with the extra lens power.
Yep, and so I just want you to tell me the same thing again. Is it clearer with or without or just smaller and darker?
Just a small and darker.
Because the patient did not prefer an additional minus 0.5 lens, we now need to refine using a 0.25 diopter sphere lens.
Yep, so I'm just going to get you to tell me what's the lowest line you can read down to now.
The fourth line, AOHT.
Yep. So I just want you to tell me the same things before. Is it better with or without?
It's almost the same.
Yep, and is it better with or without?
It's almost the same.
After establishing the initial best sphere, we can see that Hongbin requires a minus 3 lens. Step 2. Searching for astigmatism using the Jackson cross cylinder.
So I'm just going to get you to look up at the O on the lowest line you can read for me.
Natasha will begin by presenting a minus 050 Jackson cross cyl at 90 degrees. It is preferable to work in minus cylinders.
Yep, so Hongbin, I'm just going to get you to tell me if it's better with or without.
It's better with.
The orthoptist now inserts a minus 1 cylinder at 90 degrees, which will push the circle of least confusion away from the retina. Therefore, it is essential that a plus 050 diopter sphere is added to compensate for the unwanted spherical effect, therefore pushing the circle of least confusion back onto the retina. Therefore, the minus 3 diopter sphere lens is now changed to minus 2.5. In some cases, the patient may not like the lens at a 90-degree axis or at a 180-degree axis, which means we then need to check the oblique axes at 45 degrees and at 135 degrees. However, for Hongbin, our patient, this is not necessary. If they say it's better without all axes, this means the patient does not have astigmatism. Step 3. Refine the cylinder axis.
Yep, Hongbin, so I'm just going to get you to read down to the lowest line you can read now for me.
XHOTA.
Yep, and can you get down any further?
No, I can't.
Yep, so I just want you to concentrate on that O for me now. Okay, so both options may be blurry, but I just want you to tell me which one's better out of the two. Better 1 or better 2?
The axis of the 0.5 Jackson cross cyl must straddle the axis of the inserted cylinder lens in the trial frame in both of the flip positions.
Yep, so I'm just going to show you one more time. Better 1 or better 2?
Better 1.
The correcting cylinder axis is now rotated towards the minus Jackson cross cyl axis in the patient's preferred position, in this case number 1 position, by approximately 10 degrees.
And I just want you to tell me the same thing again. Is it better number 1 or number 2, or are they both the same?
Both the same.
Now that equal blur has been achieved, we have now established the patient's cylinder axis. Step 4. Refining cylinder power.
Okay, Hongbin, I'm just going to get you to look up at the chart there for me and look at the O on the lowest line you can read.
While superimposing the axis of the Jackson cross cyl with the correcting cylinder axis in the trial frame, the examiner then asks,
so I just want you to tell me the same thing as before. Is it better with or without?
Better with.
as the patient prefers extra cylindrical power, the -1 cylinder lens at 80 degrees is now replaced with a -2 cylinder lens at 80 degrees, therefore adding an extra -1 cylinder power to the script. The spherical component is now changed to -2 diopter sphere, therefore adding +0.5 diopter sphere to the script. This process is now repeated.
Yep, so Hongbin, I just want you to tell me, is it better with or without?
Better without.
We now try refining with the 0.25 Jackson cross cylinder by superimposing the axis once again over the existing cylinder axis in the trial frames.
Yep, so just keep on concentrating on that O for me and tell me, is it better with or without?
Better without.
And once again, just tell me, is it better with or without?
Better without.
Step 5. Adjusting for best sphere correction. This step follows the principles of step 1.
Alright, Hongbin, so I'm just going to get you to read down to the lowest line you can read down for me.
VXTAOUH.
Any further?
No, I can't.
So just looking at that A for me on the lowest line you can read, I want you to tell me, is it better with or just smaller and darker or better without?
Just a small and darker.
Yep, and again at that A, is it better with or without?
Better without.
Without. And again, just tell me, is it better with or just smaller and darker or better without?
It's better with.
Natasha will now change the spherical lens from -2 to -2.25, as Hongbin prefers an extra -0.25 diopter sphere.
Alright, Hongbin, so I just want you to tell me again what's the lowest line you can read down from now.
UTOAVHXT.
Hongbin has achieved best corrected visual acuity of 6.5 with a script of -2.25 with -2 at 80 degrees. To check that the patient has not been over or under corrected, the duochrome is used. It is based on the principles of chromatic aberration of the eye and is performed monocularly. The patient is asked.
Alright, Hongbin, I just want you to tell me if either of the letters stand out more on the red or the green background, or are they about the same?
They are almost the same, but the red is a little more.
As Hongbin is a myope, his response indicates that he has been adequately corrected. Overall, the reliability of subjective refraction is high. However, it can be influenced by various factors. Disadvantages. It relies on patient cooperation and ability to provide accurate responses. It can be difficult when there are language barriers and communication issues. And age. It can be more difficult with children. Advantages. It's based on the patient's preference, it's not invasive, and it's time effective.